Let us continue hydrogen and its compounds. In this preparation of hydrogen, we are discussing by electrolysis method. Now, electrolysis means we want electrolyte. Electrolyte is what in the sense acidified water. Acidified water we are taking as a electrolyte. Electrodes are platinum electrodes. Platinum electrodes. At cathode, what reaction takes place? We will see. At cathode, water goes to the cathode. Cathode in the sense reduction takes place. At cathode, reduction is possible. Therefore, water takes electron. Water takes electron. Okay. This water we can write it as like this. Water we can write it as like this. This oxygen is having two lone pairs. Cathode is giving electron. This electron is taken by hydrogen. This bond is shifted to oxygen. So this hydrogen is losing the electron here and gaining the electron here. This hydrogen losing the electron here and gaining the electron here and becomes a hydrogen atom. Here, what is the remaining means this oxygen receives this bond pair as a lone pair. Therefore, for this gain of one electron in the sense we can write OH minus. Here for oxygen we are giving -1 charge because it is gaining one electron. Therefore, we are giving negative charge. This hydrogen atom combines with another hydrogen atom to form hydrogen molecule. Therefore, hydrogen gas. For balancing this equation, what we will do means we will write 2 times water molecules, 2 times electrons and 2 times OH minus. So at cathode, what gas is produced means hydrogen gas is produced. So at cathode, hydrogen gas is produced, we can say. Next we will take anode. At anode, which species going to anode in the sense water goes to the anode. Anode in the sense oxidation. Anode means oxidation. Oxidation means loss of electrons. Now we will write a water molecule. Here in this water molecule, this oxygen is donating these 2 electrons to anode. Water is in water, oxygen is donating 2 electrons to anode. Then this bond pair is shifting to this oxygen. This bond pair also shifting to oxygen. This hydrogen loses the bond pair, loses the electron. Therefore, hydrogen get positive charge, +1 charge. This hydrogen also does same. Therefore, 2 times we can write. Then this oxygen, now this oxygen is having one lone pair here. 2 bond pairs become lone pair. Therefore, this oxygen is having 6 electrons in the valence shell. 6 electrons in the sense it is oxygen atom. This oxygen atom combines with another oxygen atom to form O2. For balancing, we'll keep off here. Okay. Let us add both off reactions in order to get cell reaction. Or overall reaction. Okay. Now we can say this water molecule I will write. Common things I will cancel. Here 2 water molecules, 2OH minus 2H plus become 2 water molecule. 2H plus 2H minus is nothing but 2 water molecules. Here 2 water molecules getting cancelled. 2 electrons getting cancelled. Here hydrogen gas is obtained at cathode. Then oxygen gas is obtained at anode. This is the product at anode. This is the product at cathode. So at cathode, hydrogen gas is produced. At anode, oxygen gas is produced. Therefore, it is a cell reaction. We can say it is called electrolysis. So acidified water in the presence of platinum electrodes on electrolysis gives what means hydrogen gas at cathode and oxygen gas at anode. We can say. So, why we have to take acidic medium? Here at cathode, water is going for reaction. At anode also water is going for reaction. Then what is the necessity of H plus? Because water is bad conductor of electricity. In the presence of acid, it becomes good conductor. Therefore, acidic medium is provided. Is it a condition that we have to provide only acidic medium, or we can provide even basic medium? That means even basic medium also we can provide. So basic medium you are providing means what is the electrolyte for that in the sense warm aqueous barium hydroxide solution. Warm aqueous barium hydroxide solution is the electrolyte. Then nickel electrodes. Nickel electrodes we have to use. Nickel electrodes we have to use. Now hydrogen gas is produced at cathode. That purity is how much in the sense greater than 99.95%. Purity of hydrogen obtained at cathode is greater than 99.5% when you use electrolyte as warm aqueous barium hydroxide solution and the electrodes nickel, but here platinum. Now you are using nickel electrodes. Okay, now purity of hydrogen obtained at cathode is how much in the sense greater than 99.95% we can see. Then we'll see properties of hydrogen. Hydrogen is colorless, it is not having odor, it is not having smell, it is not having taste. How it is burning with oxygen in the sense it is highly inflammable gas. Highly inflammable gas means what? If it catches fire, it will burn with by giving lot of energy. It is highly inflammable gas. Okay, then density we'll see. Its density is less than air, therefore we can say it is lighter than air, we can say. Then it is insoluble in water, sir. Then this hydrogen is used as what? This hydrogen is used as reducing agent. This hydrogen is used as reducing agent. That chemical properties we will see. Now we'll take palladium ion. Palladium ion, to this hydrogen gas is passed. This palladium ion becomes palladium. Palladium solid. Hydrogen gas becomes H plus ions. So hydrogen is used as a reducing agent here. Then cupric oxide is converting into copper. Cupric oxide is converting into copper. Hydrogen takes this oxygen and becomes water. Then ferrosoferric oxide, Fe3O4. It is called ferrosoferric oxide. Why? Because why it is called ferroso and ferric oxide? Ferrosoferric oxide, why is it so? Because it contains FeO and Fe2O3. Fe3O4 is mixed oxide. It is made up of FeO and Fe2O3. FeO is called ferrous oxide. Fe2O3 is called ferric oxide. Therefore, the name of Fe3O4 is given so and so. This with hydrogen gas, what happens means Fe undergoes reduction and becomes iron, and hydrogen takes oxygen and becomes water. Here hydrogen acts as a reducing agent, we can say. Next, silver chloride will take. In silver chloride, Ag is +1. That +1 Ag becomes Ag. Now Ag oxidation number is 0. Hydrogen takes Cl minus and becomes HCl. So Ag plus becomes Ag, we can say. Next we will take a tungsten trioxide. Tungsten trioxide will take. Tungsten trioxide becomes what in the sense tungsten. Tungsten trioxide becomes tungsten. Tungsten oxidation number is +6. It is becoming 0 here. Now hydrogen gas we are passing. Hydrogen gas takes oxygen and becomes water, we can say. Then we will take molybdenum trioxide. Molybdenum trioxide becomes molybdenum. Hydrogen takes oxygen and becomes water. So in the molybdenum trioxide, molybdenum oxidation number is +6. That becomes 0. Molybdenum trioxide becomes molybdenum. Okay. Then uses of hydrogen we will see. Hydrogen is used in the manufacture of ammonia, that is Haber's process. Manufacture of hydrochloric acid, then nitric acid, then methanol. So how methanol is prepared using hydrogen gas, that we will see. Now we will take carbon monoxide gas, then hydrogen gas we will take. Both gases passed over the catalyst cobalt. Now carbon monoxide combines with hydrogen to give methanol, CH3OH. Methanol is obtained. Then this hydrogen gas is used for converting vegetable oil into vanaspati or margarine, that means fat. Hydrogenation of oils will say this. So hydrogen is used for hydrogenation of oils. Now we will take oil, we will take, that means vegetable oil we are taking. To this we are passing hydrogen gas. Nickel is the catalyst. What nickel we are taking means Rane nickel. What is the name of Rane nickel means this nickel metal we have to take in the finely divided state. That means it is in a powder form. It is called a Rani nickel, we can say. Now oil with hydrogen gas becomes fat. This fat is called vanaspati, we can say. Commercial name is vanaspati. Otherwise, it is called margarine. Now, this oil is taking hydrogen and becomes fat. In the oil, CC double bond will be there. CC pi bonds will be there. That CC double bond is converting into CC single bond here by taking hydrogen. Here, since double bond is there, double bond means pi bond is present. Due to presence of pi bond here, this is called unsaturated, we can say. Unsaturated in the sense double bond or triple bond will be there. That means pi bond will be there. It is unsaturated. How many double bonds will be there in the sense? Poly. That means poly means many double bonds are there. Therefore, it is called poly unsaturated. It is called poly unsaturated, we can say. This with the hydrogen gas, we are getting what in the sense? Saturated one. Saturated means it is fat. It is not having pi bonds. It is not having double bonds. Okay. Then hydrogen gas is used for filling balloons. For what case? For meteorological studies. That means for meteorological studies, we are using hydrogen balloons. Why we are using hydrogen balloons in the sense? It is lighter than air. Therefore, it can go up. In the air, it can go up. Therefore, only we are using hydrogen balloons. But the drawback is, if hydrogen catches fire, then it will completely burn off because it is highly inflammable. Therefore, we are unable to use hydrogen gas in the balloons for studying meteorologicals. Therefore, instead of hydrogen, what is used in the sense? Helium gas is used. Why helium gas is used means helium is not flammable. It will not burn. Helium gas will not burn. Therefore, we are using helium gas. But what is the drawback of helium gas in the sense? Helium gas atomic mass is greater than hydrogen gas. Helium gas atomic mass is 4 AMU. Hydrogen gas molecular mass is 2 AMU. Therefore, helium gas is having more mass. Helium gas is having more mass than hydrogen. Even then, we have to use helium only because it is not flammable. But hydrogen is highly inflammable. Then, next uses of hydrogen we'll see. Liquid hydrogen will take. Liquid hydrogen is used as rocket fuel. Liquid hydrogen is used as a rocket fuel, you can say. Then this hydrogen is used in welding. For welding, hydrogen gas is used. While hydrogen gas is burning with oxygen and providing what temperature in the sense? 2800 degrees Celsius. It is providing 2800 degrees Celsius. That means hydrogen gas can burn with oxygen if you ignite it. You ignite and leave, then hydrogen continuously burn with oxygen. Therefore, it is used for welding. It is providing how much temperature means 2800 degrees Celsius. We have discussed already another hydrogen that is called atomic hydrogen. That hydrogen is used for welding. That is providing 4000 degrees Celsius. This molecular hydrogen providing less temperature, whereas atomic hydrogen is providing more temperature. Okay. Then regarding this liquid hydrogen, how to store liquid hydrogen, that we'll see. This liquid hydrogen, how to store. This liquid hydrogen is stored in tank. Which tank means that tank is made up of metal alloy. The tank is made up of metal alloy. And another thing, this hydrogen is highly inflammable. Therefore, this metal alloy, this metal tank, this alloy tank should be properly insulated. Okay, this metal alloy, this metal tank, this alloy tank should be properly insulated because hydrogen gas is highly inflammable. Sir. What is the metal alloy is taken here. This metal alloy is made up of what? That metal alloy formula is Na, Ni 5 times. Otherwise, we can take titanium TiH2. We can take this. Then we can take MgH2. This alloy we can take. So in this, anyone we can take it as a metal alloy for preparing tank. In that tank, liquid hydrogen is stored. This tank should be properly insulated. Sir. Then hydrogen gas is used as a fuel gas. Fuel gas. One example is water gas. In the water gas, what and all, what components are there, we will see. One is hydrogen. Hydrogen is present how much in the sense? 45 to 55% present. 45 to 55% hydrogen is present. Then methane is present. This here in this water gas, hydrogen is 45 to 50%. Then carbon monoxide. Carbon monoxide is 40 to 50%. Small amount of carbon dioxide and a small amount of nitrogen present in the water gas. Next we will take coal gas. In coal gas, hydrogen is present 45 to 55%. Then methane is present. Methane is 25 to 35%. Then carbon monoxide 4 to 11%. Next we will take carbureted water gas. Carbureted water gas. Carbureted water gas. Carbureted water gas contains what means? Water gas and hydrocarbons. Water gas and hydrocarbons present in the carbureted water gas. Next we will take semi-water gas. We will take semi-water gas. Semi-water gas. This contains hydrogen 10 to 12%, carbon monoxide 25 to 28%, nitrogen 50 to 55%, carbon dioxide 4 to 5%, methane 1 to 2%. It is called semi-water gas. So semi-water gas means we can say carbon monoxide, hydrogen and nitrogen. Water gas means we can say carbon monoxide and hydrogen because these are main substances. So next we will go for hardness of water. Next topic we are going, that is hardness of water. Hardness of water. Now, how to say whether the given water is having hardness or not? Which substance is causing hardness to the water? Now, mainly the metal cations other than alkali metal ions. In the water, what are the minerals are there? What are the mineral ions are there in the sense? Sodium ions, potassium ions, sodium ions present, potassium ions present, calcium ions present, magnesium ions present, Fe2 plus is present. So in the water, minerals are present. We are saying minerals in the sense metal cations present. Metal cations present we are saying. Sir, if the metal cations presence is considerable, then it is quite okay. If it is present large excess, that means presence of calcium ions, magnesium ions, ferrous ions, if they are present large excess, then that water is not suitable for drinking, not suitable for washing clothes, not suitable for many purposes. Even the water contains F minus ion, fluoride. The fluoride is required for the body, but how much fluoride is required for the body in the sense? Less than 1 ppm. ppm means parts per million. What is the meaning for ppm? ppm is called parts per million, we can say. What is the meaning of this one? What is the meaning of this one in the sense? Million parts of water we have take, in that how many parts of particular ions present, that is called ppm. Suppose you are taking million grams of water, in that how many grams of calcium ions present, that is called ppm. Calcium ions, magnesium ions, anything we can take. So in the water F minus is present, fluoride is present, that is required for the body. If it is present less than 1 ppm, then it is quite okay. If it is present greater than 1 ppm, it will affect the body. So minerals are required, but that should be present in a calculated quantity. Otherwise, it is causing other drawback. It is giving other drawbacks. So regarding that, we are saying in terms of hardness. Hardness word is coined based on what? Based on the water gives foam with soap. Based on that only the hardness word is coined. What is the relation between that soap and hardness? Why like this given? That we will see. Now, we will see regarding soap. The soap is called, one example for soap is sodium stearate. Sodium stearate is the example for soap. For soap, many salts are there. Many salts are responsible for soap. One salt example is sodium stearate. Soap is manufactured from fat and oil. Okay. So sodium stearate we will take. The sodium stearate formula is C17H35 COO minus Na plus. It is called sodium stearate. It is the example for soap. This sodium stearate is a solid we can take, even in liquid form also we can take. This solid soap we have taken. This formula is so and so, it is ionic compound. Here anion is COO minus, cation is Na plus. This soap is added into water. What will happen means this soap dissolves. This soap is dissolving in water. This soap is dissolving in water. Dissolved. Then it is converted into ions. It is converted into what in the sense? Ions. What is that means? Anion C17H35 COO minus anion and cation Na plus aqueous. So the salt is, this soap is dissolving in water, then ionizing into ions, dissociating into ions. This anion is responsible for what in the sense? Foam. That means froth. For froth, this anion is responsible. Due to this anion only foam is produced. Okay, the foam is nothing but this anion, we can say. The foam is this foam is nothing but this anion. Okay, foam is nothing but this anion. Okay, so why soap is giving foam, that we got idea. Now we will take the water which contains here we have taken the water. This contains what in the sense? Sodium ions, potassium ions like this. Calcium ions present in what manner? In the sense calcium ions is present, magnesium ions is present, Fe2 plus ions present, like these ions are present. But how these ions are present? In the sense the quantity of these ions is such that there is no precipitation. Why we are saying precipitation word? Sir, what is meant by here precipitation word? That we will see. Now we have taken the soap. The soap is dissolved in water as like this. Now in the water, now we will consider calcium ions present. This calcium ions combining with this anion and become what? In the sense C17H35 COO twice Ca. This C17H35 COO twice Ca. This is called calcium stearate. For this calcium stearate, we will take ionic product and solubility product. If ionic product is less than solubility product, then this is not precipitated. If ionic product is equal to solubility product, then solution is saturated with calcium stearate. If ionic product is greater than solubility product, then we can say calcium stearate is precipitated. So if calcium stearate is precipitated, then we can say the stearate ions is precipitated. Stearate ions is not in dissolved form. Stearate ions not present in aqueous solution, then foam is not there. Otherwise, quantity of foam will be less. Like that we can say. So this calcium ions will precipitate this stearate. Even magnesium ions will precipitate the stearate. Magnesium ions precipitate the stearate. Even Fe2 plus is precipitating the stearate. So due to precipitation, what happens means this anion will not be present in the solution. Therefore, foam will be decreased. So if the concentration of calcium, magnesium and Fe2 plus ions is such that if ionic product is less than solubility product, then solution will be unsaturated, then precipitation will not be there, then we can say this anion is present in the solution, then foam will be there. But these salts, that means this calcium stearate is insoluble salt. Insoluble salt in the sense, no doubt precipitation is possible. In which water precipitation is not possible? In the sense, in the rainwater in the sense, in the rainwater calcium ions will not be present. Calcium ions, magnesium ions, ferrous ions will not be present. In the rainwater calcium ions will not be present. If you apply soap, precipitation is not possible. But if you take groundwater, in the groundwater you can see that in the RO plant they will say how much salt is there, means TDS, they will say total dissolved salts. If the total dissolved salts TDS is 100 or 150, like this, means precipitation will not be there. If it is 500, 1000, 1500, like this, means you will get precipitate on applying soap. So we can say that this calcium stearate is insoluble salt. Therefore, it is going for precipitation. So that if you apply soap into water, this calcium ions precipitating the stearate. This magnesium ions precipitating the stearate. So due to precipitation, what happens? Soap is consumed, soap is wasted. Soap is wasted, we can say. So now we will take some here in this test tube. We will take rainwater. Rainwater will take. Next, take test tube we will take. In this test tube, let us take a groundwater we will take. Groundwater we are taking. Okay, same quantity of water we will take. Let us apply soap. Same quantity of soap we will apply into both. Then we will stir the contents. Then we will see the foam level. Foam level, if you see, how the foam level will be there, do you think? Where foam level will be high, do you think? Here. Here foam level will be low. We have taken same quantity of water. Same amount of soap is applied on both. But foam level will be more here. Foam level will be less here. Because some amount of soap is consumed by calcium ions for precipitating. Therefore, foam level is less. So now we are saying that this water is giving less amount of foam. Therefore, it is hard to give foam. Therefore, it is having hardness. So the hardness, the word is coined based on this foam level. This foam level is less. Therefore, it is having hardness. So how much extent foam level is decreasing, that much extent hardness is increasing. Therefore, which ions responsible for causing hardness in water? Calcium ions, magnesium ions, ferrous ions, like this, other than alkali metal ions. Other than alkali metal ions means that is causing hardness, we can say. Okay, therefore now we'll see hardness of water. Hardness of water means which water causes hardness, which in the water, which is responsible for causing hardness? Calcium ions, magnesium ions, ferrous ions, like this, other than alkali metal ions, we can say. Sir, so now we will consider two things. One is called soft water, another one is called hard water. Soft water gives lather with the soap easily. Hard water is not giving lather easily with the soap. Sir, now the hard water is not giving lather easily because of presence of salts. What are the salts? We will see. One salt we will take a calcium salts, magnesium salts, ferrous salts. Okay, here anion is bicarbonate we will take. Cation is so and so, anion is this. If water is getting hardness due to these cations and anions, then the water is called then the water we can call it as it is having temporary hardness. We can call the water is having temporary hardness. Why? Because we can remove this bicarbonate easily by boiling. We can remove these cations and anions easily by boiling. Therefore, the water causes these anions causing temporary hardness to the water, we will say. Next, we will take the water. In the water, calcium is present, magnesium is present, ferrous is present. Anion is chloride, sulfate, like this is present. Now, these salts, that means these cations and these anions, these salts causing permanent hardness to the water. Why? Because these salts we cannot precipitate by boiling. We can precipitate this one we can convert into precipitate by boiling, but this we cannot. Therefore, these salts causing temporary hardness to the water, these salts causing permanent hardness to the water, we are seeing. Sir, next, how to remove temporary hardness and how to remove permanent hardness, that method we will see. Now, one method we will take boiling. Okay, boiling we are taking. Now, this means temporary hardness. How to remove temporary hardness, that we are discussing. By boiling we are taking. Now see that any bicarbonate salt on heating will become carbonate. Okay, so you are taking metal carbonate. You are taking metal bicarbonate, you are taking. Metal bicarbonate you are taking. That on heating, what will happen means that will become metal carbonate. Metal carbonate. Any metal bicarbonate you take. Sodium bicarbonate, calcium bicarbonate, ferrous bicarbonate, like this, any metal bicarbonate you take. that on heating that will become metal carbonate. All the metal carbonates are insoluble in water except alkali metal carbonates. Take any metal carbonate that will be insoluble in water. Only one metal carbonate is soluble in water, that is alkali metal carbonates. Remaining all are insoluble. You can see the limestone rocks. Limestone rocks, you can see that limestone rocks made up of what? Calcium carbonate. Even if you see some soils, we will say that lime soil, they will say lime soil. Soil is suppose you are digging the earth. How the soil will be there in the sense of white manner it will be there. That they will say lime soil, like this they will say. How do we say lime soil? To that you add HCl. Brisk effervescence will come. That means carbon dioxide gas comes. That means that consists of lot of calcium carbonate. Such a type of soil is there, means that is good for plantation of tomato, like this, which and all is rich of calcium, which vegetables and all rich of calcium, that will be planted in that soil. Sorry. So we can conclude that all the metal carbonates are insoluble in water except alkali metal carbonate. Okay. Now temporary hardness means which one you see? Which is causing temporary hardness? One is calcium bicarbonate. This calcium bicarbonate is causing temporary hardness. Okay. This bicarbonates, in the sense all the bicarbonates exist only in aqueous solution. They cannot exist in solid state. Any metal bicarbonate you take, that will exist in aqueous solution only. That will not exist in solid state except alkali metal bicarbonates. Alkali metal bicarbonates alone exist in solid state. Remaining bicarbonates, calcium bicarbonate, we can't prepare in solid state. Solid calcium bicarbonate we cannot prepare at all. We can prepare aqueous solution of calcium bicarbonate alone, we can prepare. So the water contains bicarbonates, what and all, in the sense calcium bicarbonate, then magnesium bicarbonate, then ferrous bicarbonate. These are present in the water in aqueous form, not in solid form. Not in solid form. Bicarbonates never exist in solid state. Okay. Alkali metal bicarbonates exist in solid state. Okay. These bicarbonates is boiled. On boiling, what happens means this will become calcium carbonate. Calcium carbonate is precipitate, insoluble salt. This becomes magnesium carbonate. It is insoluble in water. It is insoluble in water. Ferrous bicarbonate, it is becoming FeCO3. It is insoluble in water. Sorry. Now, since they are precipitated as carbonates, just filter and remove. You can see this one, you take water in a vessel, groundwater you take, boil it. You see that vessel, afterwards pour out the water. After boiling, pour out the water. You see the vessel, inside the vessel you see white coating will be there. That white coating is what? Calcium carbonate. This carbonate salts only that white coating. Sir, that means these bicarbonates we can remove by boiling. On boiling, these bicarbonates are precipitating as carbonates. Another possibility is there. This magnesium bicarbonate can precipitate as magnesium hydroxide. Magnesium hydroxide precipitate. For this, solubility is less than magnesium bicarbonate. For this, solubility is less. For this, solubility is high. Therefore, magnesium bicarbonate mainly precipitating as magnesium hydroxide. Okay, so calcium bicarbonate is precipitating as calcium carbonate, magnesium bicarbonate is precipitating as magnesium hydroxide. Okay, so how to remove temporary hardness? Take water, boil it. The temporary hardness causing salts becoming precipitate. Calcium bicarbonate is precipitating as calcium carbonate. Magnesium bicarbonate is precipitating as magnesium hydroxide. Then go for filtration. We can remove the precipitate. Now the filtered water is not having hardness. That water is called soft water, we can say. Next, for removing temporary hardness, another method is used. That method is called Clark's method. That method is what means Clark's method. Sir, in Clark's method, how to remove temporary hardness, that we'll see. Now, in the Clark's method, what is used in the sense, quicklime is used. In the Clark's method, what substance is used in the sense, milk of lime is used. Milk of lime is used. Then another one is there, slaked lime is there. Slaked lime. Both have formula same, calcium hydroxide. Both have formula calcium hydroxide. Milk of lime and slaked lime both are having formula CaOH twice. Then what is the difference? It is called aqueous solution of calcium hydroxide. It is suspension of calcium hydroxide. That is the difference between these two. Suspension in the sense that is not clear solution. That is not clear solution. And not clear means what? Calcium hydroxide, some insoluble calcium hydroxide also presents. That is the meaning. So we will take milk of lime. We will add calculated quantity of milk of lime into water which contains temporary hardness. So temporary hardness means which is causing temporary hardness? Calcium bicarbonate, magnesium bicarbonate causing temporary hardness. Okay, now we will take milk of lime. Let us add milk of lime into this one. In which method? In the sense in Clark's method. Milk of lime we added. Milk of lime in the sense aqueous solution of calcium hydroxide. Now what happens means here it is base. Bicarbonate is having acidic hydrogen. This hydrogen is acidic hydrogen. H plus is there. So this OH minus is abstracting this H plus and becomes water. Then calcium ion is there, carbonate ion is there. Calcium carbonate is always insoluble. Therefore, calcium carbonate is precipitated. We can say calcium carbonate is precipitated. So this OH minus is taking this H plus and becomes water. Then calcium and carbonate becomes calcium carbonate. So calcium carbonate is precipitated, we can say. Then we'll take this one. Magnesium bicarbonate and quicklime. This milk of lime. This magnesium ion takes hydroxide and becomes magnesium hydroxide precipitate. This OH minus takes H plus and becomes water. Then calcium takes carbonate and becomes calcium carbonate. Then another bicarbonate in which carbon dioxide gas comes out. So magnesium bicarbonate with milk of lime. With milk of lime, we are getting a magnesium hydroxide precipitate, calcium carbonate precipitate. These we can remove by filtration. So the calcium bicarbonate, magnesium bicarbonate is converted into precipitate that we are removing by filtration. The filtered water is not containing now these. Therefore, the filtered water we can say that soft water we can say. Okay, so this is called a Clark's method we can say. Let us stop.